Because the whole point of an index is to be a shortcut between a question and an answer, you really can't talk about indexes without talking about how they're going to be used. So SQL Server has a query optimizer that looks at the available indexes and the statistics, tries to guess how many rows will be returned from different operations, and it plans out the lowest cost method of answering a question. And there are a number of logical and physical operations, but I want to talk about 5 here that are critical to understand. The first one is a table scan. And when you see a table scan inside of a query execution plan, what SQL Server is doing is starting at the beginning of the table, reading in and then scanning in memory every data page in that table. And it's important to note that it's not always a physical operation because SQL Server does an excellent job of prefetching and keeping the right data pages in memory. So if they're used frequently, they'll already probably be in memory, which is why SQL Server is more CPU bound and memory bound than IO bound in my opinion. Table scans are useful when it's reading in a large percentage of data, and it's going to be faster just to quickly scan all of that inside of memory than individually seeking out particular rows. Another common operation is the clustered index scan. And a clustered index scan is special because it doesn't have to scan the entire data, it can scan a range of data, and usually that's what's happening. SQL Server knows we only need to find all the data from this row or this data page to that row or that data page, and it'll determine the beginning and end point and then just scan in a portion of the data. So clustered index scans are excellent at pulling in a large block of data from a huge table. Clustered index seeks navigate the B tree and then find with surgical precision a specific row. And of course it has to read in the entire data page, but it's a quick way to find a certain row. And when you see clustered index seeks in the query execution plan, it doesn't necessarily mean it's finding only one row. It might be finding 500 rows, but it's going to show you one icon of a clustered index seek. Then there's a non-clustered index scan, and this is where SQL Server is scanning either a range or all of the data of a non-clustered index. In the non-clustered index seek, it's finding a specific row or several specific rows in a non-clustered index. And I have to talk about a bookmark lookup here for a second. Both with the non-clustered index scan or seek, there's a good chance SQL Server will need to have more information than just the columns that are part of the non-clustered index, in which case it will then have to jump over and also find those same rows as part of the clustered index. In the non-clustered index, there's actually 3 types of columns. The first columns in the non-clustered index will be the key columns, the columns that are actually sorted for the non-clustered index. The second set of columns in the non-clustered index are actually the keys of the clustered index. So if SQL Server needs to find more data about that row in the non-clustered index, it can use the clustered index keys to go find the entire row in the clustered index. And new to SQL Server 2005 is the ability to include other leaf columns in the non-clustered index. So these are columns that are not sorted, they're not part of the clustered index, they're just extra columns of data. And they're extremely useful because that way you can avoid having to do an expensive bookmark lookup to go find additional information. And the bookmark lookup is often the most expensive part of a set of queries that are being executed frequently. So when you have a non-clustered index, there's really only 2 options. The first option is that the non-clustered index completely covers the need of a query, and we call that a covering index, meaning that it completely covers the needs of the query. So every column needed by the query, whether it's in the select statement, the order by, the where clause, everything needed by that query can be solved using only the non-clustered index. And having those new included columns really makes that nice, because we can build covering indexes without having to add other indexes in the key index, because we don't have to add key columns, but we're putting them there just to fake out SQL Server so we could build a covering index. So I said there's 2 options with a non-clustered index. The first is that it serves as a covering index, and that's the ideal, that's what we want. The other option is if it fails to be a covering index, SQL Server will have to do a bookmark lookup. When I analyze systems and I use SQL Server Profiler to capture all of the queries being sent for a day and then I analyze it, do a group by, what I typically find is that there's just a handful of queries that are performing 90% of the work. And I want to make sure that those queries that are doing 90% of the work are all being solved by either the clustered index or by a covering index. And I'm trying to avoid the bookmark lookup. A bookmark lookup is fine for those other 200 queries that constitute maybe the last 5% of work. But for the bulk of the work, we desperately want to avoid bookmark lookups. So I want to take a look at a few execution plans right now. And hypothetically, let's say we have a table with the name of table. And there are two indexes. On the right is the clustered index, which is clustered on column 1. And then in the leaf nodes, there's column 2, 3, 4, 5, and 6. So that's the clustered index. And on the non-clustered index, there's column 4 and 5. Those are the two key columns. And there's column 1, which is there only because it's part of the clustered index at the end of the non-clustered index. So, with this clustered and non-clustered index in place, we want to try to guess what will SQL Server do to solve the query of select star or all columns from table where column 1 is equal to 7. And because column 1 is there as the key of the clustered index, it becomes an excellent SARG or searchable argument. And this will be a lightning fast search using an index seek in the clustered index. Let's see this on a live query. I'm going to jump over to AdventureWorks. And the production transaction history table is a large table, has 113,000 some rows in it. Let's go ahead and look at how it's set up. Here's production history. It has a primary key and one foreign key. Transaction ID is the primary key. Looking at the indexes, here's transaction ID, it's clustered. There's also product ID, which is the foreign key. It's a non-clustered index. And then there's reference order ID. And I'll open this up. The reference order ID is a composite index, meaning it consists of two columns in the key column. So, use AdventureWorks, we're already there. And I'll execute this. But first I will turn on to view the execution plan and then execute it. Pretty quick. View the execution plan, and sure enough we see a clustered index seek. You'll notice that it has the parentheses around the view of the B tree, and the dark blue line looks like it's seeking right down to a specific row. If we mouse over this, it'll show you a lot of information about what SQL Server was estimating, which is not just there as an academic thing, because the whole point of the query optimizer is to guess or to estimate the number of rows that will come out of a certain operation and the CPU cost and I/O cost, and try to figure out what is the cheapest way. So the estimated information is actually pretty important. Down in the object of this box, you can see what object it was looking at. The seek predicates tell you how it was navigating that B tree. So that's the first example, clustered index seek. So we have the same clustered index, same non-clustered index. This time we want to answer the query of select star from table where column 4 is equal to the value of 7. Now, if there was no non-clustered index and we simply had to find everything where number 4 was equal to 7, that would not be a very good searchable argument because there's no index there for it. SQL Server would be forced to do a table scan or to do a clustered index scan and scan the entire clustered index. But we have this non-clustered index right here, and what we're going to do is do a non-clustered index seek to find the row equal to number 7. Then it will have to jump over to the clustered index so it can get the rest of the columns because we're saying select star. So let's see that. And reference order ID is an index. It's a non-clustered index. And so that's going to be our predicate there, our searchable argument or SARG, and execute. Man, that was very fast, wasn't it? So, execution plan. You'll see here is the non-clustered index seek, where it went down, and if you look at the seek predicates, where it went down and found the rows where the reference order ID was equal to 55555. Then it had to jump over to the clustered index seek, and it found the rest of the data where it matched up, and I had to do a nested loop join to pull that information together and then present it.